Hey everybody, it's Dr. J with the second part of Weather and Flying. This presentation is lengthy, therefore I suggest you consider watching it in 6 to 8 minute chunks and taking a short break after each chunk. As a kind reminder, while you may question what some of this information has to do with flying a drone, remember that some of this information is contained on the FAA Part 107 exam for drone pilots. FAA restricts drones to flying at 400 feet or less. Therefore, clouds are rarely an issue. However, the remote pilot could occasionally encounter clouds. Cloud type is determined by its height, shape, and behavior. They are classified according to the height of their base as low, middle, or high clouds. Clouds are mostly composed of water droplets since their bases generally lie below 6,500 feet. However, when temperatures are cold enough, these clouds may also contain ice particles and snow. Clouds are the most problematic to remote pilots. They can produce snow, ice, rain, or hail that interferes with flights. Fog is a form of a low cloud. Bases of middle-level clouds typically appear between 6,500 to 20,000 feet. Because of their lower altitudes, they are composed primarily of water droplets. However, they can also be composed of ice crystals when temperatures are cold enough. Their height. Middle-level clouds are only a problem for aircraft pilots. Remote pilots should not have an issue with middle-base clouds. Level clouds form above 20,000 feet, and since the temperatures are so cold at such a high elevation, these clouds are primarily composed of ice crystals. High-level clouds are typically thin and white in appearance, but can appear in a magnificent array of colors when the sun is low on the horizon. Ceiling refers to the lowest level of clouds reported as being broken or overcast. Ceiling is important to remote pilots since low clouds can appear below 400 feet. Keep in mind that FAA regulations require that drones be flown via line of sight. If the ceiling is below 400 feet, the altitude at which the drone can legally be flown is reduced. Meteorologists use descriptors for identifying the cloud level in the sky. A clear sky means there are no clouds or just an occasional cloud in the sky. A description of a few clouds means that less than 1/8 of the sky is covered with clouds. A description of scattered clouds means that approximately 1/8 to 1/2 of the sky is covered with clouds. Broken clouds means that approximately 5/8 to 7/8 of the sky is covered with clouds. Overcast means that the sky is completely or almost completely covered with clouds. A thunderstorm cell, during its life cycle, progresses through 3 stages: the cumulus, the mature, and the dissipating. It is virtually impossible to visually detect the transition from one stage to another, as the transition is subtle and by no means abrupt. Furthermore, a thunderstorm may be a cluster of cells in different stages of the life cycle. The initial stage in the development of an air mass thunderstorm is that in which rising, warm, humid air develops into a cumulus cloud. The mature stage Precipitation falling from the cloud base is a signal that a downdraft has developed and a cell has entered the mature stage. Updrafts reach speeds exceeding 6,000 feet per minute. Up and downdrafts in close proximity create strong vertical shear and a turbulent environment. Downrushing air spreads outward at the surface, producing strong, gusty surface winds, a sharp temperature drop, and a rapid rise in pressure. The downdraft's downward speed is accelerated and may exceed 2,500 feet per minute. Cold rain in the downdraft retards compressional heating, and the downdraft remains cooler than the surrounding air. Downdrafts characterize the dissipating stage of the thunderstorm cell, and the storm dies rapidly. When rain has ended and downdrafts have abated, the dissipating stage is complete. When all cells of the thunderstorm have completed this stage, only harmless cloud remnants remain. Wing icing is a concern for flying in cold weather. Some individuals mistakenly think that wing icing only occurs at high altitudes, but it can occur when an aircraft is on the ground if there are two conditions present. First, there has to be water droplets present, and second, the air temperature must be at or below freezing. Including remote pilots, must be attentive to the weather. The FAA issues what is known as a METAR, which stands for Meteorological Terminal Aviation Routine Weather Report. METARs typically come from airports or permanent weather observation stations. Reports are generated about once an hour or half hour, but if conditions change significantly, a report known as a special may be issued. Remote pilots can receive METARs through an app on their smartphone. The first time you read a METAR, it will make absolutely no sense. METARs are issued in a standard international format. Once you understand the format, they are easy to read. This is what a typical METAR looks like. As you can see, for anyone who does not know how to decipher a METAR, it can make little sense. Two types of reports, the METAR and SPECI. The METAR report is the standard report that is issued. The SPECI report refers to a special report that is frequently issued as an update to the original METAR. The first notation indicates that this report is the standard METAR report. The second notation is the station identifier. All stations, which are usually airports, in the lower 48 states, begin their identification with the letter K. Some of the websites that contain the METAR provide links so you can see what airport the station identifier refers to. The third notation is the date and time the METAR was issued. The first two numbers are the date. When METARs expire, they are removed. Therefore, when you see a METAR, it is relatively current and you know it is for the present month. The last four numbers are the time in Zulu time. Zulu time is used so that all weather measurements taken at different locations and time zones around the world can be made at the same times. If you do not already know how to read military time, you will need to do so to read a METAR. In this example, 1753 hours translates into 5:53 p.m. We know this because when you subtract 12, which is the time at noon, from 1753, the result is 5:53. Since we know this time is after noon, we know it is 5:53 p.m. The next thing we need to do is figure out the difference in the time zones between where we live and where Zulu time occurs. Zulu time occurs at 0 degrees longitude prime meridian which runs through the Greenwich, England area. North Carolina is in the Eastern Time Zone. There is 5 hours difference between Zulu Time Zone and the Eastern Time Zone, except during Daylight Savings Time, when the difference is 4 hours. This means that the alert was issued at either 12:53 p.m. or 1:53 p.m. Eastern Time, depending upon whether Daylight Savings Time was being observed. Airports automatically generate the METAR. When this happens, the METAR contains the notation auto. Occasionally, METAR reports are issued as a correction to a previous report. In these instances, they will contain the notation COR for corrected METAR. Notation contains wind information that is found within 5 digits. The first 3 digits refer to the direction from which the wind is blowing. In this example, the wind is blowing in from 140 degrees. The next 2 digits refer to the wind speed in knots. If there is a reportable characteristic about the wind, such as that it is gusting or variable, then this will also be indicated. For wind that is gusty, the final numbers indicate the highest recorded wind speed. This notation refers to the visibility, which is reported in full and fractions of statute miles. This notation contains descriptors about the weather. If the information is preceded by a minus sign, the weather effects are light. If there is no sign in front of the information, the effects are moderate. If there is a plus sign in front of the information, the effects are heavy. Names and letters identify the weather descriptors. This slide depicts the codes for these weather descriptors that are used by the FAA. The next notation provides the sky condition. The 3-letter code at the beginning of the notation refers to the cloud conditions that I previously covered. The number after the 3-letter code indicates the altitude at which the condition begins. This number represents in hundreds of feet where the condition begins. Here we can see that cloud cover is broken beginning around 800 feet. At around 1200 feet, the sky becomes overcast. We can also see that vertical visibility is about 300 feet. The codes that are used to denote the different cloud conditions. This notation refers to the temperature and dew point. This information is given in degrees Celsius. If the temperature is below 0, it is preceded by the letter M to denote a -degree reading. The final notation refers to the barometric pressure. The reading is followed by a notation as to whether the pressure is rising or falling. The weather report type is the convective significant meteorological information, or convective SIGMET. This report is issued when significant thunderstorm activity is present in the area. An example of a convective SIGMET. As you will note, it depicts a line of thunderstorms moving into the area. The storms will be active on November 3rd from 11:55 a.m. to 1:55 p.m. Pacific Standard Time. The area affected is from the surface up to 37,000 feet above sea level. This concludes our review of the presentation on weather and flying. Thanks for watching.